Chapter 8.3, Reflecting Points and Graphs. So in Chapter 8.1 and 8.2, you guys looked at translating points and graphs, and we're going to now take a look at another transformation called reflection. Okay, reflection is a transformation that flips a figure or a graph over a line, creating a mirror image. When you guys learned about symmetry, line symmetry, reflection symmetry, mirror symmetry was one of the big ones. Okay, a heart has line symmetry. A butterfly is another common example. So the transformation of that, actually reflecting something, is the process of reflection. Okay, and that flips. We use the word flips because it's something that you can understand. Good mathematic vocabulary would say that we reflect an image over a line. Okay, and there's two main reflections that we'll talk about with graphs. A reflection across the x-axis and a reflection across the y-axis. When we reflect across the x-axis, we're going to change the sign of the y-coordinates. Okay, if you think about it, basically something that is up here, if we reflect it across the x-axis, goes down here. Okay, so the y value changes. From the worksheet that you guys went through at the beginning of the unit, if you remember, when we reflect across the x-axis, xy goes to x comma negative y. The x stays exactly the same, the y value goes negative. And same thing in the reflection across the y-axis. If we look at this, this is just something here that goes here. Okay, what's changing there is the x value. The x value changes sign. Okay, so again, in our opening activity, the coordinates x, y transformed to negative x comma y. So you can pause the video and get down those three definitions there onto your note sheets. I'm going to move on to a couple of examples here. Okay, so we're asked to look at each example of a parent function and its image, and then describe the transformation when and then write a function for the image. So let's start with the absolute value of x function here. We learned in 8.2 about translating functions. So you can see we have a translation and a reflection. Okay, I'm going to start with the reflection. Okay, we have reflected this absolute value sign across the x-axis. It is down below. So right away we know that when we reflect across the y or the x-axis, y changes. Okay, so we reflected across the x-axis, and our y values will change. Then we've translated 1, 2, 3, 4 units to the left and 1 unit down. We've translated 4 units to the left and 1 unit down from our original. Okay, so that would be a description of the function. Reflection across the x-axis, translation 4 to the left, 1 down. Okay, so you can get that there. Let's talk more about what that does to our function. Okay, our parent function is y equals the absolute value of x. That's what we started with. We know that a reflection across the x-axis changes the sign of the y values. Okay, so when we reflected, we went to negative y equals the absolute value of x. Okay, our y's went positive, or went negative. When we translated to the left, you guys learned in 8.2, a translation to the left is actually an addition inside of the absolute value sign. So that is going to be an x plus 4. Okay, if we add 4 to the x's, that's a translation to the left on a graph. And then down 1, that's a subtraction of 1 unit outside the absolute value sign. Okay, now to really get this to be a y equals function, I'm just going to take this negative sign and bring it over here. Okay, we can do that that's affecting not the x value but the y value, so it's outside of the absolute value, and that's our final function there. This y equals negative the absolute value of x plus 4 minus 1. Okay, and we can test that out with some points. Here we have the point 1, 1, and that works with our function. Our parent function y equals the absolute value of 1. 1 equals the absolute value of 1. Okay, so that works there. Let's see what 1 will be in our new function. So if we plug 1 in for x, y is going to equal negative the absolute value of 1 plus 4 minus 1. Okay, so y equals the absolute value of 1 plus 4. That's going to be the absolute value of 5, the negative 5 minus 1. That should be y equals negative 6. And if we look down here, our new function is at 1 comma negative 6. So we've done our translation, or we've followed all our rules correctly. That's a nice way to always check your work to see if you have done the correct equation for your translation or reflection. Okay? All right, then let's take a look at this y equals f of x function. There's a couple ways to look at this. We can say that this is a translation over and down, okay? Or we can look at this movement as a reflection across the y-axis, okay? So reflecting across the y-axis is the same in this instance as just translating it over. Let's see, we go from negative 8 to 0, so we're going over 8 and down 6 to get to our new function. So if we're going to describe that, we could either say translate to the right 8 and down 6, or we can say reflect across the y-axis and translate down 6. So there's two options there. Let's look at the actual reflection of the function at first. Let's use that since that's what this unit is doing. Okay, when we reflect across the y-axis, so this is our parent function, y equals f of x. When we reflect across the y-axis, our x values are changing signs. So to express that in our function here, I'm just going to make a negative x, okay? Because now where y was f of x, this, let's say, at negative 2, 6, that translated to y of negative x. So a negative negative 2 would be positive 2, and that's where we are. Okay, so that would be 2 of comma 6, 2, 6. Okay, f of 2. Now we have to also include the translation downward. Okay, when we translate down, remember we can just say that's a minus on our equation. So I'm just going to say that's minus 6. Okay, and that should give us our new function, y equals f of negative x minus 6. Okay, and if we plug in another point there, let's say f of 2 is now where it should be. All right. For class, I'd like you guys to try your best to come up with an equation, both a description of the transformation and an equation for this red line on the left side of the y-axis here. We'll go over it in class, so if you are struggling through it, don't fear. We will go over it, but make sure you attempt to get an equation for that line.